Okay, in this video I'm going to give an example of drawing a waveform for HDB3 scrambling, and this is built on an AMI signal. And just to review quickly, AMI, alternate mark inversion, takes a 0 voltage or a 0 bit and gives a 0 voltage, and a 1 bit and alternates between plus V and minus V. And I'll label it V0 here to match the figure here where I have the voltages is V0. Okay, so with AMI encoding, the problem is that long strings of 0 gives us a flatline voltage, which causes problems when we're trying to synchronize our receiver and our transmitter. And so this HDB3 scrambling takes strings of zeros and replaces them with a pattern that is recognized by the receiver so that it can remove those. And the HDB3 scheme takes 4 zeros in a row and replaces them with either 3 zeros and what's called a bipolar violation, or a B00V, where B is a normal bipolar transition, meaning a normal scheme of alternating between plus and minus, and V is a bipolar violation. V stands for violation here. Okay. If the number of non-zero pulses since the last substitution is odd, then we use the first one. Number of non-zero pulses since the last substitution, meaning an HDB3 substitution, is odd, and we use this one if it's even. Okay, and so I hope that this example will give you an example of each. What I've done here is I've sketched out a bunch of bits, and down here I'm going to draw this pattern with this AMI pattern with HDB3 scrambling. Okay, so let's see here. We start with a 0, so that gives us a 0 voltage. Now we have a 1, and a 1 means we've alternate between plus and minus V. But we don't know what the previous one was. Let's assume that it was negative. The last non-zero voltage before we got to the starting point here was negative. That means that our 1 is going to take us up to a plus V. Now this 1 takes me down to negative V, the next one. And that's called a normal bipolar transition. That's what a B would look like. Okay? Now I have 4 zeros in a row. And 4 zeros in a row means I do the substitution, and I'm going to assume furthermore that we had an even number of non-zero pulses since the last substitution. Okay? And in that case, I'm going to use the B00V pattern. And I recommend writing the substitution pattern right under the bits in a problem like this, or somehow indicating what the pattern is going to be. And so a normal bipolar transition means that I do the normal thing as if it were a 1. And then 2 zeros gives me 2 zeros. And then V is a violation, meaning that instead of alternating plus and minus, I'm going to have 2 pluses in a row. Okay? So a B is like a normal 1 that alternates, and a V is a violation. And so now I have a 1, which gives me a normal bipolar transition, a 0, which gives me 0 volts, a 1, normal bipolar, and now I have 4 zeros in a row again. And so I have to ask the question, which is it? The 000V or B00V? And So I have to count the number of non-zero pulses since the last substitution. Well, the last substitution ended here, and I have 2 non-zero pulses, and so it's even. And so I'm going to use the B00V again here. And I have 2 non-zero pulses. And a B00V gives me, a B looks like a normal 1, 2, 2 zeros, and now a violation where I go down twice in a row. So each violation takes me the same voltage as the previous non-zero. Now I got 4 zeros again. I have to do another substitution, and there are clearly 0 non-zero pulses since the last substitution. Since these two substitutions are right in a row, 0 is an even number, so I get another B00V. Okay, and so the B acts like a normal 1, 2 zeros look like 2 zeros, and a violation goes like this. Now I have 2 more zeros, a 1, which gives me a normal bipolar, a 0, 2 1s in a row, and now I have yet another substitution. And let's see how many, let's count how many non-zero pulses since the last one. 1, 2, 3. Aha, now we have an odd. So we have, since the last one, we have 1, 2, 3, which is odd. And so we're going to use the 000V substitution, and we're going to get this, and then the violation looks like this. Because the previous one was negative, so I violate the alternating pattern. And finally, a 1, another 1, a 0, and a 1, all following normal bipolar alternating pattern. Okay, so hopefully this example helps you understand all of that, and thanks for listening.